Okay. The first question that I would like to ask you for this card, because this card I will talk about the mass and energy balance. Why we have to study the mass and energy balance? Anyone can help me to understand to answer this question?
To calculate and find the property of the substance.
Okay, that is it, the basic data to support to do the mass balance also. If you know the property of data, you can make the energy balance. But my question is why we have to do or to study the mass and energy balance. Another answer. Why it is important to study the mass and energy balance. Energy balance. The mass means we have to know amount of the substance in our process, and also we have to know the energy, amount of energy in our process. We talk about the process for petrochemical and chemical engineering. Talk about the process. If you know the mass, if you know the energy in your process, you can design your system. You can calculate. You can analyze the economic. You can analyze the possibility of your process. If you know this quantity, mass, and energy, this is very important. For example, in distillation column, you would like to separate crude oil. You have to separate crude oil to be benzene, gasoline, kerosene, something like that, or diesel, something like that. If you would like to produce benzene or diesel from the crude oil, the first step you have to know how many amount of crude oil. How many amount of crude oil, how many benzene that you produce, how many diesel produce, how many methane produce, and also how many energy incorporate in the system. And then if you know amount of energy, you can predict the economic potential. You can calculate the money that you have to use to produce. You have to calculate we call it the cost. The cost. And okay, you can predict the profit, something like that. You can predict the profit. You can predict the revenue, something like that. If you know mass and energy, if you math and energy, you can predict the condition. You can calculate the condition to operate in your process. And also the last step in chemical or petrochemical engineering, you can analyze the economic potential. You can calculate the cost. You can calculate the revenue. You can calculate the profit. The profit of your company. Okay, this is very important and it's basic subject that you have to study in the petrochemical engineer. The math and energy. Okay, I will give you the basic, simple. In human body or animal body or microorganism also. For this case, I talk to you if you eat some medicine. If you get some medicine, you get some food. For this data, you get some medicine. And also you get some food. Okay. If you check your body weight at the morning and in the evening, if you eat some food, your weight is increased. It's maybe 60 kilogram. And then you eat breakfast, is lunch, and evening. Okay. At the evening or the next tomorrow, you weight your body. The weight is increased because you have the food. You have medicine into your body. We can calculate this based on the mass of food, mass of medicine. Mass of food, mass of medicine. And also, in your body, you have the metabolism. If you study the biology at high school, your metabolism, Your metabolism means the body reaction. It's also the biological reaction, chemical reaction, and also in your body we have some biological reaction. In your body, you change the food, you change the medicine, that's right, convert to another substance. It's maybe in terms of the energy, like ATP, adenosine triphosphate. That's right. Sometimes your body convert your food into the ATP for energy for your body, and also convert carbohydrate to sugar. That's right. And also this is for your body, for growth. Okay. This is the food feed to your body, and also some conversion. That's why we have input. Okay. We have generation or consumption in your body. That's why generation means you get new substance in your body. You get ATP in your body. What consumption? Consumption that your food convert. That's right. Food convert to another substance. That's right. Carbohydrate convert to sugar. Sugar convert to energy. So you have some convert, right? Some conversion. The conversion means consumption, right? Use. And generation means you get a new substance in your body also. This is the same chemical reaction. Right? For chemical reaction, we have reactant, we have product. Reactant is consumption. Product is generation. That's right. Okay. And also we have output. In your body, we have the output like excretion. That's right. Excretion is maybe in terms of liquid, in terms of solid. That's right. Urine is in terms of liquid. In solid, that's right. In terms of so that's right. Is for the solid weight or liquid weight, something like this. Is urine. This is the mass out. That's right. Mass out. Mass in like the medicine, like the food is the input, is output from your body. And also in the plant, the output is maybe your product, it's maybe weight, it's maybe byproduct output. The input is the raw material, that's right, raw material. And the generation is maybe reaction, product generate. Consumption is maybe reactant consume. And also the last term, accumulation. While your body, your weight is increased, that's right. When you eat the food at the morning and at the evening, your weight is increased. We call this term accumulation. That's right. That's right. Accumulation. If you eat a lot of food, and then many accumulation, you get a fat boy. That's right. Fat girl. This is the effect of accumulation. That's right. Accumulation. This is the basic term that I talked to you. That when you eat the food or when you get the medicine in your body, you have the food medicine at the input. And also in your body, we have the excretion in the food and or in urine, urine in the output. And also in your body, that's why your body convert carbohydrate to sugar, convert sugar to energy. That's why sugar also generate, energy also generate, but carbohydrate is consumed. That's right. We have the generation, we have the consume. And also there are some mass accumulate in your body. You will increase in your weight. We call it the accumulation. Okay, this is the term include in your body and also include in the petrochemical plant. That's right. Petrochemical plant. This for mass and also energy is the same. We have some energy input. We have some energy output. We have some energy accumulate. That's right, accumulate. And also energy generate or consume, something like this. This is the overall. We would like to talk about the mass and energy balance. That's right. We have input, we have output, generation, consumption, accumulation. That's right. For mass and energy balance. I compare to your body, but it's easy to understand. That's right. Like why we have the increase your weight. Okay. You have to control the food. It would like to control the accumulation. That's right. If input equal to output, what does it mean? No accumulation. no generation, no consumption. That means input equal to output. Your weight is the same every time. That's right. Your weight is the same every time. That's right. Today is 60 kilogram. Tomorrow is also 60 kilogram. That's right. In 2 days also 60 kilogram because your food feed to your body equal to the food out of your body. That's right. That your weight is the same for this case. Okay. I will show you some example of the petrochemical plant, something like this. I show you the technology for produce the benzene. That's right. We would like to produce the benzene from the toluene and hydrogen. That's right. The toluene and hydrogen is the input material. That's right. Input material. And also benzene and flue gas is also output material. And also in the process, there are some generation consumption of toluene consumption, hydrogen consumption, and also benzene generation, flue gas generation, and gas generation. And also a lot of energy incorporated in the system. That's why we would like to talk about the mass balance and energy balance for this process. For this class, you can do that. You can do overall balance, or you can do the balance around reactor, that's right, or balance around distillation, something like that, or mix unit. You can balance the mass around single unit or multiple unit or overall process. You study in this class, that's right. You study in this class, and also the basic you can make the mass balance for your body, right? For today morning and tomorrow morning, you can check your mass balance. I think your mass will increase a little bit because you some eat food in your body, the mass increase, and also in your body we have some reaction. That's like generation, consumption, and also accumulation. You can check your body like this technique. This is for example, right? And it is the process for to produce DME. DME for methanol as the raw material. That's right. Raw material, and also we get the DME. You get the wastewater in the output. That's right. For this case, you can make the overall mass balance. When you do the mass balance, you have to identify what is the feed. That's right. What is input? What is output? What is the generation? What is the consumption, and what is the accumulation. That's right. But this can give you some example why we have to study the mass and energy balance. That's a mass energy balance. Okay. Okay, this is the general mass energy balance equation. As I talked to you already, that's the first step. You have to identify the system. That's right. What is your system? It's maybe if you balance your body, okay, your body is the system. But in case we have the block diagram in this system, and have some MI, MO, MI means mass in and mass out. That's right, mass in and mass out. The general equation I talked to you already. You have to mass into the system battery, mass feed into the system to this battery, minus mass out to the system for this battery. It's mass in minus mass out. That's right. Also has mass generation. That's right. And minus mass consumption equal to mass accumulation. Right. If we would like to know how many kilograms that increase during a day when you eat the food, something like that, this is the mass accumulation in the system. It may be increased or decreased. That's right. The accumulation may be increased or decreased. Mostly it depends on time. Vary with time. For this case, it's vary with time. In petrochemical or chemical engineering, the generation and consumption, we concentrate only in the reaction. We concentrate on reaction. That's a chemical reaction. And also in biological reaction. But we did not consider the nuclear reaction for that case. We only consider the chemical reaction. Okay. The generation for product, more is product. This is reactant. If you balance on product, you have 1, 2, 3, 4 terms. There is no consumption. That's right. If you balance on reactant, there is no generation. It depends on what kind of you balance. If you balance on total mass, that's right. I will talk to you later. There is no mass gen, there is no mass consumption for total mass. Why? Because reactant convert to product. That's right. Product also come from reactant. This term is balance. If you balance overall or total mass, there is no generation, no consumption, and no consumption and generation. That's right. It depends on what kind of you balance. You balance on species, on water balance, sugar balance, oxygen balance, or the total mass balance. That's right. Okay, this is the general question. For the general energy equation, and also the same, energy in minus energy out, and equal to energy accumulation. That's right, the energy accumulation. But for energy, we have at least 1, 2, 3, 4 terms of energy. This is the input, this is the output, and also we can calculate based on heat and work. Q is heat, W is work. As that heat can transfer between system and surrounding. Work also can transfer between system and surrounding. Sometimes when you study with the class, Q is positive or negative, depend on the textbook, or it depends on the definition. For this case, the Q positive when surroundings receive energy from the system. For this case, it is surrounding. That's right. Allow the system. If surrounding receive the energy from the system, okay, which is a positive. That's right, positive. Okay. Or the system receive the work from the surrounding, the work is positive, like this. Okay. We talk to you in detail again. Right. The basic energy we have U is the internal energy. EK is kinetic energy, EP is potential energy, PV is for work, something like this. Kinetic energy. I think this you study in the physical. What is the kinetic energy? Lika, are you hear me, Lika? Could you explain about the kinetic energy? What is the kinetic energy?
Kinetic energy is the energy that an object possesses on its motion. Okay, that's the main. It is the motion or the movement of the object. That's right. This is the kinetic energy. If the system is no movement, okay, there is no kinetic energy. When the kinetic energy is based on the movement of the equipment, movement of the stream, movement of the fluid. Okay, because this is the kinetic energy. And the potential energy, Angelo, could you describe about the potential energy?
It is the energy related to its position, Ajahn.
Okay, this is based on the difference of position, location. That's right. If the difference of the height of the location is delta Z, delta S, something like this. And the last one, internal energy. Who can explain about the internal energy? Could you help me to describe? Pongson, could you explain about the internal energy? What is the internal energy? You know about the internal energy? Do you know about it, the internal energy? You need your friend to help you.
There is a energy that contained inside the something.
I think it's quite similar to kinetic energy, but we consider in the atomic level or molecule level. That's right. Okay. The internal energy means the energy that incorporate in the atom or molecule. That's vibration. That's right. The vibration of the molecule, the vibration of the atom, the movement of the molecule, the movement of the atom. That's right. For internal energy, it's the microscopic movement, but for kinetic energy, it's the macroscopic movement. Right. Different the level. Okay. In the internal energy, more chemical engineering, we consider this because it depends on the difference in the movement, the vibration, the difference in energy for each atom, each molecule in our system. Okay. This is for the internal energy. And also we have two types of the energy that can be transferred from system to surrounding, from surrounding to the system. We have the heat and work. That's right. The heat can transfer from the higher temperature to the lower temperature. That's right. And also work in chemical engineer or chemical engineer, we have at least two work that we consider. Sharp work and flow work. Sharp work, like mostly we talk about the mixing system. That's right. We have sharp work or the mixing system. We have the mixing, we have the motor to rotate the impeller. That's right. And another work is flow work. That's right, the flow work. This is the energy that we have to consider for the energy balance in this class, right? Kinetic energy, potential energy, internal energy, heat and work. Okay, this is the basic definition term. Okay, and this show you the topic that we will talk about, the mass and energy balance. That's right, the mass and energy balance. Okay, I will talk to this already. And the second topic, we will introduce you about the basic calculation technique, the unit and the dimension. That's right. And the third topic, we talk about the process and variable, like the temperature, the pressure, what is the unit of temperature, what is the unit of pressure, what is the force, what is the weight, what is the concentration, what is the flow rate, what is the mass fraction, what is the molecular weight, something like this. We will talk about this, how to measure the temperature, how to measure the pressure. We introduce you in the topic 4. And topic 5 to 6. 5 and 6, we consider like the 4 to 6. Okay, 4 to 6. We consider the material balance or mass balance. That's right. Mass balance. Mass balance for non-reactive. For this case, there is no reaction. And for the case of reaction, we have also single and multiple process. And I talk to you in this, the process diagram. If we would like to consider for single unit, okay, we can make a mass balance around this unit. That's right, around for single and multiple, this may be mass balance around these two or overall. You consider. That's right. Okay. And topic 7 and topic, we introduce you about the single and multiple phase system. Number 7, single phase system, liquid system, vapor system, solid system, or multiple liquid gas, liquid vapor, liquid solid, something like this. And also the last topic, we will concentrate on the energy balance. The last one, okay. The computer aid will be move to the last topic. Energy balance. And also energy balance, we concentrate on the reactive system and non-reactive system also. That's right. And answer state, okay. Computer aid calculation. And another topic should be yes, right. Most of, or I will talk to you topic 4 to topic 12. We talk about the steady state. There is no accumulation table for this case. For the case with no accumulation term, we talk about the steady state system. But the last topic, I also will introduce you about the unsteady state. We have input, output, generation, consumption, and also accumulation. For this case, you will get ODE or PDE. What is this? You studied the calculatory already, right? If we consider the unsteady state, it maybe will solve ODE or PDE. That's right. Or the linear differential equation or partial differential equation. But only for input, output, generation, consumption, we consider the algebraic equation. That's an algebraic equation. You maybe solve the metric only, not ODE. If you consider the unsteady state, you will solve by ODE technique or PDE technique. But for this class, it's only basic ODE. I will show you only the basic ODE. Okay, before we start the first topic for the engineering calculation, for this case, I will introduce you about the engineering calculation basic, the unit, the dimension, aside, how to fit the curve, how to representation your data, right? And also how to use the significant number, something like that, introduce you for the next topic. Okay, do you have any question? I would like to break for 10 minutes and I will start again after 10 minutes. Do you have any question for the introduce about you, the class?